All right, assalamu alaikum everyone. I hope you guys are all doing well. I'm going to start today's session in a minute. Can someone please confirm if you can see my screen? Can you guys see my screen?
Yes, sir.
All right. Thank you. Okay, so today what we are going to do is we are going to start quadratic inequalities. Okay, so we'll see how to solve quadratic inequalities. Until now, we've talked about different properties of quadratic functions. They're just two major concepts that are left in this topic. And one of them is solving quadratic inequalities. We'll do the other one hopefully tomorrow or maybe the day after tomorrow. And then we'll wrap this topic up, inshallah. Okay, so let's start with this quadratic inequalities. Okay, so we want to be able to solve quadratic inequalities now. Let's start with an example. Let's say we have this equation. We have x squared minus 7x plus 12 equals 0, first of all. Okay, this is a quadratic equation. We know how to solve this equation. We can do something like this: x squared minus 4x minus 3x plus 12. So we basically break the middle term. Okay, and then we factorize this. It becomes x into x minus 4 minus 3 into x minus 4. That equals 0. Now we get two factors from this: x minus 3 into x minus 4 equals 0. And you get two answers. One is x minus 3 equals 0 or x minus 4 equals 0. These are the solutions to this quadratic equation. So in fact, from this you get x equals 3, and from this you get x equals 4. These are the solutions to this quadratic equation. All right. Now, what about inequalities? What if instead of an equation, we had an inequality? So for instance, something like this: x squared plus or minus 7x plus 12 greater than 0. What do we do? What do we do about this now? How do we solve this? Now, one thing that you might think of doing first would be that you just factorize this, just like you factorize it for solving quadratic equations. You factorize this and you end up with the same factors, which are x minus 3 into x minus 4, and you say that is greater than 0. All right. And then you might think that either x minus 3 is greater than 0 or x minus 4 is greater than 0. But we cannot really do this. In equations, we could do something like this because we had two expressions, this multiplied by this, and the result was equal to 0. That meant if these two numbers were multiplied, the result should be equal to 0. Now that is something that is only possible if at least one of these expressions is equal to 0. Otherwise, you cannot have a product that's equal to 0. So if you have two numbers and their product is equal to 0, then it's necessary for at least one of them to be equal to 0. All right, so that's why we say either x minus 3 equals 0 here or x minus 4 equals 0. All right, so for an equation, it works like this. However, for an inequality like this, if you've got two expressions and they're multiplying and the result is greater than 0, it's not necessary that both of them are greater than 0. It's not necessary. Why? Because you could also have two negative numbers. You could have -2 and -3, let's say. If you multiply these two numbers, their product is going to be greater than 0. All right. So you can't solve quadratic inequalities like this. You can't just split the factors like this. This would not be correct. You cannot do this. All right. Similarly, if you had another inequality that looked like this, x squared minus 7x plus 12, that's less than 0. If you were to factorize the left-hand side, you would have gotten the same factors, which is x minus 3 and x minus 4, and that would be less than 0. Now here as well, it would be wrong to assume that x minus 3 is less than 0 or x minus 4 less than 0. That would not be correct. Again, similar reasoning. If you had two numbers, and you were to multiply them and the result was supposed to be negative, it does not mean that both of these numbers have to be negative, because if both were negative, then the result would actually turn out to be positive. So only one of them can be negative and the other has to be positive. Then you get a negative result at the end, less than 0 result at the end. Okay. So the first thing to understand is you cannot solve it the usual way, the way that you used to solve quadratic equations. That method is not going to work here. Okay, so you cannot do something like this. This would be wrong. All right, so that's the first thing you need to realize here. Now, once that is done, let's see what actually we need to do then. Okay, so what method we are going to use to solve quadratic inequalities then, if not this. Let's start with that example, with one of these examples. So let's say x squared minus 7x plus 12 greater than 0. Let's try and solve this equation, this inequality. X squared minus 7x plus 12 greater than 0. How exactly are we going to solve this inequality? What you do is you first treat this as an equation. You treat this as an equation. And that is going to give you 2x intercepts of this function. All right. So that's the first thing you do when you're solving quadratic inequalities. You treat this as an equation. Now, you solve this equation. We have solved this before. We get two factors from this. So we first do the middle-term breaking, minus 4x minus 3x plus 12 equals 0. And that gives us two factors, x minus 4 and x minus 3 equals 0. And there are two values that we get from this, x equals 4 and x equals 3. Now, until this point, it's exactly the same as solving an equation. All right. Now, think about what this function is going to look like. X squared minus 7x plus 12. What exactly does this function look like? Now, first of all, it's a U-shaped curve. Why? Because the coefficient of x squared is positive. This coefficient is positive. So it's a U-shaped curve. It's going to be like this. And we're getting two x-intercepts for this. The two values where the graph cuts the x-axis. So if this is the x-axis, which is actually the line y equal to 0, you're getting two values where the graph cuts this axis. They are 3 and 4. These are the 2 points which you get from this equation. All right. So first of all, you're going to find those 2 points that you get from the equation. All right. And now once you're done until this point, you look at the inequality now. The inequality is that this whole function, rather than being equal to 0, which would be on this line, rather than being equal to 0, this should be greater than 0. So what you do in this case is you look at the graph and see which parts of the graph are above the x-axis. Where on the graph is the value of the function something positive? All right. So you see, where is the graph above the x-axis? There are two regions where the graph is above the x-axis. One region is towards the left here, and the other region is towards the right here. These are the two regions where the graph is above the x-axis. All right. Now, what are the corresponding values for x that you've got in these two regions? Well, on the left side, you've got values of x which are towards the left side of 3. And this right region, here you've got values of x which are towards the right of 4. So you have two separate regions which satisfy your condition. One of those regions is x less than 3. That's the region towards the left of 3. And the other region is the region towards the right of 4. And you would say these are the two possible answers for this inequality. So either x is less than 3, then it would satisfy the inequality, or x is greater than 4, and then as well, your inequality would be satisfied. All right. So this is how you would actually solve this inequality. We first treat this as an equation, find the x-intercepts. Once we have found the x-intercepts, we look at the graph and see which regions on the graph satisfy our condition. All right, where the graph is above the x-axis. Now, let's take the other inequality, this inequality that we also wrote there. Let's try that now. So the other inequality was x squared minus 7x plus 12 less than 0. This was the other inequality. How do you solve this inequality? Again, what you do is you treat this as an equation first. You say x squared minus 7x plus 12 equals 0. So the first thing you do is you treat this as an equation. And then you solve that equation. You factorize this. You've done this before. The factors turned out to be x minus 4 and x minus 3. These were the two factors that we were getting, and we got x equals 4 and x equals 3 from this. These were the two values that we were getting, which were the x-intercepts of the graph of this function. And that will look like this. Okay, something like this. Let me try to be a bit more accurate. Okay, so it's going to be a U shape like this, which is symmetrical. Now, this is the x-axis. And you're getting two x-intercepts for this. One is 3, the smaller one, and the other is 4, that's the bigger one. These are the two values of x that you're getting on this graph. Now, in this case, you need to notice that you have a less than sign here. Okay. So you're looking for the part of the graph where this whole thing is less than 0, where the whole graph is on the negative side. All right, that's what we're looking for. So where is the graph on the negative side? Below the x-axis. Since you have the less than sign here, we're looking for the part where the graph is below the x-axis. That is this region. This is where the graph is below the x-axis. All right. Now, what are the values of x that satisfy this condition? On the x-axis, you can see the values are between 3 and 4. This is the region that you've got on the x-axis for this. So how do you write down the answer for this? You say x is between 3 and 4 like this. Okay. You always write this as a single inequality like this, not as two separate inequalities, because it's one single region. It's one single region. It means x is greater than 3, and at the same time, it's also less than 4. So it's greater than 3 and less than 4. This is how we write this answer in this case. We cannot write it separately. If you write it like this, x greater than 3 and x less than 4, that would not be correct, because that would actually mean x is greater than 3 or x is less than 4. Okay, if you write inequalities separately like this, it means there's an or between them, and that's not what we want. You want an and between them, and for that we have to write them as a single inequality like this. And this is going to be the solution for this. You can remember it this way. When you've got the regions on the sides which are correct, you have two separate regions, one region here, another region here. So you write that as two separate answers, x less than 3 or x greater than 4. When you have a single region, that's the region in the middle. In that case, you write it as the one single inequality because it's one single region. Okay, it's one single region here, the region between 3 and 4. So this is going to be our final answer here. All right, some people write it like this: 4 greater than x greater than 3. Although that also makes sense mathematically, but what we do conventionally is that we write the smaller number on the left side and the larger number on the right side. Then we have the less than signs in the middle. So I would recommend that this is what you do, because this is what's recommended in the marking schemes and not this. Although it can make sense mathematically as well, that 4 is greater than x and x is greater than 3, but they normally prefer it the other way around, that you write 3 on the left and 4 on the right. So the smaller number on the left side and bigger number on the right side. Okay, so this would be your final answer. You would not write it like that. Okay. So this is how we solve quadratic inequalities. I hope that makes sense. Let's take a couple of more examples on this, and then we'll do some practice questions. Let's say you have this inequality, 2x squared minus 7x minus 4 less than or equal to 0. Now you've got this inequality. Now, how do we start? The first thing that you're going to do is you're going to treat this as an equation. Treat this as an equation. What does that give you? That gives you 2x squared minus 7x minus 4 equals 0. And now you solve this equation. How do we solve this equation? We can factorize this if we want. It becomes 2x squared minus 8x plus x minus 4 equals 0. We take 2x common, and that leaves us with x minus 4 inside, plus 1 into x minus 4. And we get two factors from this, 2x plus 1 into x minus 4 equals 0, which means either x equals minus 1 over 2 or x equals 4. These are the two values for x intercepts that we're getting. Now again, we draw a U-shaped graph, and we say the x intercepts of this graph that we're getting are minus 1 over 2. That's on the left side. That's the smaller number. And 4, which is the other x-intercept. These are the two x-intercepts that we are getting. These are the solutions for this equation. But we were not solving an equation. We were actually solving an inequality. This is the sign that we've got there. Less than or equal to. So now on the graph, you're going to look for the region where the graph is below the x-axis. It's less than 0, right? So where is the graph below the line y equals 0? It's this region. Okay, and how do you write this region? It's between minus 1 over 2 and 4. So you write it as a single inequality like this, between minus 1 and 4. And now, since this question has an equal to sign there as well, in your final answer, what you're going to do is you're also going to put the equality signs there. So it's x between minus 1 over 2 and 4. So whenever you have the equality signs there as well, you're also going to put them in your answers. So this is the result that you get from this. All right. Now, let's do one last example before we move on to some practice questions. Let's say we've got something like this. Minus x squared minus 7x minus 12 greater than or equal to 0. Now we've got an equation like this. Now, whenever you've got something like this, you can either solve it directly, which will be okay. But in that case, since the coefficient of x squared is negative, the graph that you make will be an inverted U like this. And then you'll have to look at that graph and think about the possible cases that you've got from that. But I would recommend that you always convert it to a U-shaped graph first. And how would you do that? In this inequality, you can multiply the whole thing by -1 first. Okay, that could be the starting point here. You multiply the whole inequality by -1. Remember, however, whenever we multiply or divide an inequality by a negative number, we have to flip the sign. So right now it's greater than or equal to. What you can do is you can flip the sign, and now that inequality that you had there is converted to this inequality. And now you just solve it like any other inequality. Now forget about the original one. Now this is what you're solving. X squared plus 7x plus 12 less than or equal to 0. And this is the sign that you're going to consider at the end, less than or equal to 0, when you draw a U-shaped curve. All right. Now, what do we do after this? We treat this as an equation. We say x squared plus 7x plus 12, that is equal to 0. Find the values of x that satisfy this equation. You can say x squared plus 4x plus 3x plus 12 equals 0. We get two factors from this, x plus 4 and x plus 3. And they give us two values of x equals -4 and x equals -3. Okay, these are the values of x that we're getting from this. So again, what we do is we draw the x-intercept here. This is how, so the x-axis here, the x-axis is going to look like this. The x-intercepts that we're getting are -4 and -3. So you need to think about which region, which number is smaller. -4 is smaller, right? So that's going to be on the left side, -3 on the right side, because that's the bigger number. Okay, and now what's the sign? It's the less than or equal to sign. So which region are we looking at? We're looking at this region that is below the x-axis. So the values of x that you've got then are between these two values. So your solution should be x between -4 and -3. This is how you're going to write this inequality as the final solution. If you were using the original inequality, remember it would have looked the other way around. Your graph would have been an inverted U like this. If you were drawing the original inequality, it would be like this. And then the x-intercepts would be like this. -4 and -3. And in that case, you had a greater than or equal to sign. So in that case, you would be looking at the region that is above the x-axis, and that will be again this region. And the answer from that also would have been the same. That's x between -4 and -3. All right, so that is if you were considering the original inequality, but for that, you'll have to keep in mind that the shape of that graph would be an inverted U, okay, and not this one. So if you convert it to this form where the coefficient of x squared is positive, then the inequality sign would change and it would become a U-shaped curve. From both of them, you get the same answer. So you can work with it either way. All right, so I generally would prefer converting everything to a U-shaped curve. So that basically standardizes things in your mind. And you can actually just remember this as well. once you've converted everything to U-shaped curve, whenever you've got a less than sign, you will always get this middle region, the region between the 2 points. And whenever you've got a greater than sign, like we got in this example, for instance, you would always have regions on both sides. So smaller than the smaller value and bigger than the bigger value. So you'll have regions on the sides when you have a greater than sign. When you have a less than sign, you would have region in the middle. That is going to be true whenever you've got a U-shaped curve, all right? Because in a U-shaped curve, the region below the graph, below the x-axis is going to be in the middle, and the regions above the x-axis are going to be on the sides. So when you convert everything to a U-shaped curve, you can also, just remember this in your mind, that whenever you have a less than sign, you'll have the region in the middle. Whenever you have the greater than sign, you'll have the region on the sides of the two x-intercepts that you find. All right. So this is the method for solving quadratic inequalities. What do? We treat this as an equation, find the x-intercepts, which are the cutoff points, then see from the graph which region or regions are correct. Okay. Any questions on this? Any problems, anyone? No? All right. So this is how we solve quadratic inequalities. Then let me just write down the steps here. So we have, we first need to make sure that the coefficient of x squared is positive, right? That's what I generally do. If it's not positive, I make it positive. Okay, so that's the first thing that you do here. You say if the coefficient of x squared, it's going to make things easier for you if you do it this way, because you'll always get a U-shaped curve. If the coefficient of x squared is negative, first of all, what you do is you multiply the inequality by -1. Okay, when you do this, the inequality sign will also change. So you need to keep that in mind. The inequality sign will also change. So that's the first thing we do if needed. If the coefficient is negative, then you can do this. Then what you do is you treat this as an equation. Treat it as an equation and find the x-intercepts. Okay. And once you've found them, you sketch a U-shaped graph. Why? Because you would have already converted it to a U-shape in the first step. A U-shaped graph to see which regions are correct. If you have less than or equal to signs, the middle region is going to be correct. the region between those two x-intercepts. And if you have greater than or equal to signs, the side regions, the regions on the sides, they will be correct. Okay, I'm sorry, I got disconnected there. So these are the answers that we get from this: m less than -10 or m greater than 2. Now, what you would have to do here would be you have these different cases for solving quadratic inequality for the discriminant b square minus 4ac greater than 0, equal to 0, less than 0, greater than or equal to 0. In these three cases, the first, the third, and the fourth ones, you'll have to solve inequalities. All right. So you can use this method for solving quadratic inequalities to basically find the values of the unknowns that you have to find there. All right. So this is how it works. This is how we solve quadratic inequalities. This is the method that you can use for solving any quadratic inequality. This is the summary. All right, that's it for today. In our next class, we will be doing some more practice questions and also discuss that one last concept that is left. And then we wrap this topic up, inshallah. All right. So thank you. I'll see you again in the next session. Allah Hafiz.